Hello everyone, my name is Ruyang Gao from Peking University. Today, I'm honored to present my work entitled Towards Position-Independent Sensing for Gesture Regulation with Wi-Fi. Gesture is a user-friendly way to easily convey information, which has become an important topic in HCI to support various applications such as smart home control, games, and AR. Among different gesture regulation approaches, Wi-Fi-based sensing approach results a widely deployed Wi-Fi device that can perform sensing tasks. By analyzing the channel state information (CSI) of Wi-Fi devices, the motion and the behavior of users' hand are speculated. Despite the progress achieved, there is a fundamental problem called position dependency problem. The problem is that signal patterns vary significantly differently for a same gesture with different position. As shown in the figure, users draw digital 2 with different location and orientation. The patterns of received CSI variations are very distinctive, limited by the ratio. The existing pattern-based and facial feature-based approaches cannot recognize gestures in position-independent manner. How to relieve the position dependency problem? The key of approach is that instead of observing hand motion from transceiver's view, we recognize gesture for the hand-oriented view. A gesture can be consistently characterized by how the hand moves relative to its previous position. Such a hand-oriented view can provide consistent and distinguished representation for different gestures, which are relevant to its location and orientation of the hand. We'll first talk about how to extract features from hand-oriented view, then we'll explain how to recognize gestures with the feature. We observe that the changing pattern of moving direction of the hand keep constant in different locations. Example, user draw digital 2 with different positions and orientation. The changing patterns of the moving direction keep constant. Therefore, we develop a novel feature named Motion Navigation Primitive (MNP) to capture the changing patterns for gesture regulation. The problem is how to extract the consistent MNP from a raw signal. To answer this question, we will think about how to characterize the moving direction of the hand. The velocity of the hand can be projected into two velocity components along any non-parallel axis. As shown in figure, the ratio of two velocity components are monotonous with the moving directions. Therefore, we calculate the ratio to capture the changing pattern of moving directions. How to obtain projectile velocity components? The velocity component can be geometrically connected with the reflection path changes on one pair of transceivers. Utilize two pairs of transceivers, we obtain two velocity components and calculate their ratio. How to estimate the reflection path changes? Reflection path is physically connected with the dynamic phase of the signal. Every time the reflection path changes by one wavelength, the dynamic phase changes 2 pi. Therefore, we extract the dynamic phase changes to estimate the reflection path changes. The MNP can be extracted by the ratio of dynamic changes from two pairs of transceivers. Now, we explain how to use MNP for identifying gestures. The MNP captures the changing patterns of the moving direction of gestures, which is sufficient for position-independent sensing. The slope of the MNP are correlated with the speed of direction changes. Faster MNP changes, greater the slope will be, and the increasing or decreasing trends of MNP are correlated with the clock directionality. Complicated gestures can be decomposed into a combination of strokes, which is line, arc, and color. Each type of strokes corresponding to different moving direction change speeds. Their MNP patterns are also distinguishable. The temporal sequence of the stroke can act as the representation for gestures in regulation. We built a prototype called WeGesture to verify our idea. The system consists of 3 modules to recognize gestures in real time. The input gesture is identified by comparing its temporal sequence with the reference. We run WeGesture on 3 different gesture sets, including basic gestures, digital gestures, and conducting gestures. The average recognition accuracy is more than 22% high. We made 3 contributions in this work. We propose a hand-oriented view-based strategy to relieve the position dependency problem. We designed a concrete position-independent feature MNP, which captured the changing pattern of moving direction for gesture recognition. We built a prototype system which validates our methods. Thank you.